All right, so we're working with basic fundamental trig identities today. So here's an example problem. We're going to let you try one here in a couple of minutes and give you a few like this on a practice assignment. Use the given value and trig identities that we've talked about today to find the indicated trig functions. For this assignment, okay, and for our exercises today, go ahead and assume all the angles are acute angles. So we're only dealing in the first quadrant. So over here, you can see that we have tangent of beta equals 3. So that's what's provided to us. You may say, well, tangent of beta equals 3. Great, what does that tell me? Well, get into the habit of representing things with a triangle. Okay, so let's go ahead and draw a triangle. I'm going to come over here on the side, maybe just right here. Let's draw a right triangle and represent things. So beta, so there's our angle projecting out. So if tangent equals 3, tangent, SOHCAHTOA. So tangent is opposite over adjacent. So opposite over adjacent. Well, if that equals 3, couldn't I write it this way? That's 3, and that side is 1. 3 over 1. Now I could do 6 and 2, I guess. I could do different ratios that equal 3, but let's go as simple as we can, 3 and 1. So if that's the case, let's finish off our triangle here. What would be the hypotenuse? Well, Pythagorean Theorem, so 1 squared plus 3 squared, so that's 10. So this side is the square root of 10. Now, with this triangle in front of us, can we answer these pretty easy? I hope so, right? So let's go ahead and run through these together. So cotangent of beta. Well, cotangent is just the reciprocal of tangent, so that one's pretty straightforward. It's just 1/3. Cosine of beta, SOHCAHTOA, again, cosine is adjacent over hypotenuse, so that would be 1 over square root of 10. Tangent of negative beta, ooh, so this is where those even odd identities come in, so that's the equivalent of negative tangent of beta. Well, tangent beta is 3, so this one would just be negative 3. Not too bad. Cosecant. Okay, cosecant, that's not as natural maybe to think of. At least for me it's not. So I like to remind myself, oh, cosecant is 1 over the sine, right? So sine, in this case, in fact it's easier if I just do sine beta, I like to do it this way. Sine would be opposite over hypotenuse. So that's 3 over root 10. And so then cosecant would just be the reciprocal, root 10 over 3. Okay, so big idea here. You run into something, draw a triangle, label it as best you can, and then let's use our knowledge. Use SOHCAHTOA, use what we know about these different identities to try to figure things out. Okay?